Hi guys. So today I want to talk about a concept called pre-algebra. For some of you guys, it might be a little easy or it might be a little bit daunting, but don't worry, it's a really easy to understand concept and it's a very interesting one. So on the right here, I have three examples of arithmetic, and I'm assuming you guys have a little bit of arithmetic like experience. So these three equations are examples of arithmetic where we do uh, either addition, subtraction, multiplication, or division. And yeah, you're basically manipulating numbers to find their results. Now, in over here, this is where algebra really begins. So, algebra. Let's look at this first one. What is this? So this is a seesaw, and I have drawn here a seesaw to help explain what algebra is all about. So on the left side, we have 5 dots, and on the right side, we have 5 dots. So this represents 5 equals 5, and this is kind of obvious, but it might get a little bit confusing in the second one. So in the second one, we have a big blue circle on the left side and 5 small dots again, no, 7 small dots on the right side. So this represents circle equals 7. What is circle? So circle is, in this case, a variable. And a variable can have many values in certain situations, but in this situation, circle is equal to 7. And it cannot have any other value to make this statement true. You can't make circle equals 6, and if this circle is equal to 6, then this seesaw would not hold, and this equation therefore would not be true. So circle has to be 7. Now in the third example, we're making this a little bit more complex. So what does this represent? This is a circle plus 4 equals 8. Now how do we solve this? So what can circle, this equation is asking what circle has to be for this equation to be true. So let's try 3. If this circle is equal to 3, would this hold? So 3 plus 4 is equal to 8. Is this true? No, it's not. So therefore, this circle cannot be equal to 3. Now we can go on and guess and check, which is the strategy we just used, but we need to there's a simpler and more effective way to solve this problem. If we just subtract 4 from each side of these equation, we got that circle is equal to 4. And that's in this seesaw scenario, if we take off 4 dots from each side, we're just removing it, we can see that we are left with circle equals 4. And therefore, we're getting the same equation, whether we do it visually or algebraically. So, here's an example of a question that uses this algebra. So suppose we're trying to find the length of ruler B. And these two rulers, in this case A plus B is one ruler, the rulers are equal to each other. So in equation form, it would be 19 is equal to 5 plus B. And in this case, again, B is our variable because we don't know what the value of it is, and we are trying to find what the length of ruler B is. So how can we do this? Well, just like we did last time, we can remove 5 inches off of each of the rulers to find that b is equal to this part is 19 minus 5, which is 14. So b is 14 in this example, 14 inches. Now, algebraically, if we subtracted 5 from each side of the equation, we get that 19 minus 5 is equal to b, or 14 is equal to b. So, as you can see, this is basically the same thing. We just subtracted 5 from each side of the equation in this visual format and in this algebraic format. So I hope you could see the potential in this concept, and I hope you have fun further exploring the concept of pre-algebra.